All right, welcome back. Our last topic here in Unit 5 is the applications of trigonometric functions. It's pretty much just right triangle trig, law of sines, law of cosines in a word problem format. So recognizing what kind of triangle we need to draw to solve the scenario and then using the appropriate trig knowledge to solve for whatever side or angle is missing. So just a couple things to kind of talk about. So for the right triangle trig questions, they're typically in terms of angle of elevation or angle of depression. The angle of elevation, as this graphic that I got from a textbook is showing us, is the angle that's measuring from the ground up. So you're on the ground, and it's the angle that you're elevating your eyes or whatever's going on the movements. They talk about, you can think of angle of elevation in relation to the movement of your eyes. Looking straight ahead, you must elevate your eyes to see the top of the tree. The angle your eyes move at, that's your angle of elevation. Whereas the angle of depression is technically outside the triangle, and it's measuring from the top down. Now, the nice thing is the angle of depression does match the angle of elevation, so we just fill it inside the triangle there, and then just kind of solve out the problem from that scenario. So just be careful with the wording when they talk about angle of elevation, angle of depression in these kind of problems involving the right triangle. So a blimp is flying 500 feet above the ground. A person on ground sees the blimp by looking up at a 25-degree angle. Person's eye level is 5 feet above the ground. Find the distance from the blimp to the person. So if we draw out a right triangle for this scenario, they tell us that the person's looking up at an angle of 25 degrees. So our person is right there. Their eye level is at 5 feet above the ground, and since the blimp is 500 above the ground, this vertical portion is 495 then, because you're already 5 feet above when your eyes are looking to get to the 500, so it's 495. And they want the distance the blimp is from the person, so that would be this side right here. Because the blimp is here, person is here, the hypotenuse is your unknown they were looking for that. So if they wanted the horizontal, how far blimp is horizontally from the person, then we'd want that horizontal value, the missing side. So we look at this scenario, we see that our 495 is opposite 25 degrees, the x is the hypotenuse, so this would be sine. So sine 25 equals opposite over hypotenuse. We cross multiply, x sine 25 equals 495. Divide over sine 25. So 495 divided by sine 25 will be 1,171.27 feet. So make sure you always remember, include your units. Do pay attention to the direction. Sometimes they'll talk about rounding to the nearest foot or inch or whatever is going on there. So give the appropriate rounding tool based on what they tell you. If they don't give you a certain one, then obviously we round like we do in class, which is typically to the thousandths place. Obviously in this case, that's not what we're doing. But that's because, again, when you look at your full decimal value here, so our 495 divided by the sine 25, make sure, again, you are in radians mode, otherwise you're going to get something wrong. So I have 269, so the 9, that third digit would round up because of the 7 after. That's why it's just 27 went to the hundredths place. But the other thing is, again, watch out for the 495. You're not using 500 because you already accounted for 5 feet from where the eye level begins to do your angle. So this scenario, we have a hot air balloon that's moving above a neighborhood and has an angle of depression of 28 degrees to one house, 52 degrees to a house down the street. So we have essentially this right triangle scenario right here where we've got two locations. So this first location would be your 28 degrees, and while it's an angle of depression, remember that corresponds to then the same location for the angle of elevation. That would be your 52 degrees. You can clearly see which one is which because that's 52 degrees should be a bigger angle because it looks like a bigger size there. It tells the height of the balloon is 650, so that part is 650, not 62. Estimate the distance between the two houses. So house 1 is here, house 2 is there. We want this distance. So to find that distance, we're going to want to find this z value right here. You can call it whatever you want. I'm going to call it z. Because the x is part of that triangle that's not a right triangle, so we're going to use a law of sines, law of cosines question for that one, but it shares the z side, which is part of the right triangle, using the 650 and the 52 degrees. So we can go ahead and say sine of 52 equals 650 over z, cross multiply, and then divide over the sine 52 with the 650. So 650 divided by sine 52 is our 824.862, but you got to make sure you store that exactly since you need to use that value to solve something else. Again, refer to the calculator video showing you how to store variables if you need help with that, but make sure this exact value after you do the 650 sine 52 is stored exactly. So now, inside that triangle, we got to get a couple other angles. So we know that the angle next to the 52 would be a supplementary angle, so this has to be 128. The missing tiny angle on the very top is an exterior angle with the 52 and the 28, meaning this is a 24. So this setup, now we can see that the 24 is opposite the x, so it's sine 24 over x, and then sine 28 over z. That allows us to solve for side z. So when we cross multiply, we get x. Z sine 24 equals x sine 28. Trying to solve for x, we divide over the sine 28. So in your calculators, you're using obviously your parentheses for the sine functions and the alpha z, or whatever you stored z as. So alpha z sine 24, close parentheses, divided by sine 28, close the parentheses, and you're going to get 714.637 feet. All right. As always, make sure you're using exact values throughout the problem. You don't want to use round off answers in the middle of the question. It's going to lead to rounding errors, which will lead to inaccurate results. So that's a kind of combination of using the right triangle trig and the law of sines question in the same problem. All right, here we got Jackie and Peter doing a figure skating routine. They skate apart with an angle of 15 degrees between them. Jackie skates for 5 meters, Peter skates for 7. How far apart are the skaters? So there's no longer a right triangle. So the angle between them was our 15 degrees. Jackie is going 5 meters. Peter is going 7 meters. So we want to find the distance in between them there, x. This is going to be, well, that looks like a law of cosines because we have side angle side, trying to solve for the third side. So we would say x squared equals 5 squared plus 7 squared minus 2 times 5 times 7 times the cosine of 15, where then obviously we'd have to square root that whole big thing. So when we do all that, we're going to get 2.527 meters, because now we're in meters for this problem. And because we're not using this answer to do anything else, we don't need to worry about storing it. Obviously, if we had to solve for a missing angle now, we would have to store the value of x and then move on from there. So we're just recognizing that it's no longer a right triangle trig question, simply because we have a non-right angle being created here. All right, so let's just take a look at one last question. Two observers are standing on a shore half a mile apart at points A and B. Okay, so we got points A and B. They're half a mile apart, so I'll just say that's 0.5. And they're looking at a sailboat at the sea at point C. Okay. Angle A is 63 degrees. Angle B is 56 degrees. And find the distance from each observer to the sailboat. So I want to find this distance x, this distance y. So we're going to need to solve law of sines questions because, again, this is not a right triangle. We'll need to know what angle C is. So we just go ahead and subtract the 63 and the 56 from 180. So when we do that, we get 61 degrees. So that's angle C. So if I want to solve this out, we're going to set up our law of sines ratio. So we would have sine 56 over x, sine 61 over 0.5, and sine 63 over y. So obviously we would work with just the sine 56 over x, sine 61 over 0.5 to solve for x, and then we'd use the sine 61 over 0.5 and the sine 63 over y to solve for just y. All right, cross multiplying. Getting our x sine 61 equals 0.5 sine 56, and dividing over the sine 61. So as long as you're careful with your parentheses there, you should be getting x to be a value of 0.474. Distance is miles, so it would be miles. We do the same thing for y. We cross multiply y sine 61 equals 0.5 sine 63. We divide over the sine 61 again. Again, being careful with your parentheses. And we're going to get y to be 0.509 miles. All right, so it's just simply a small taste of the different types of questions you could see involving your law of sines, law of cosines, or right triangle trig in a word problem format. Just draw the triangle scenario that they create for you and then just solve the question from there. All right, so that's it for our triangle units with trigonometry. So next up is going to be more dealing with angle measurements in trig, unit circle, graphing, all that kind of stuff. So I'll see everyone next time for Unit 6.